All right, you guys, today we're looking at quadrilaterals. Specifically for today, we're looking at just the broad category of quadrilaterals and what makes a figure a parallelogram. So we're starting off here just in general, what is a quadrilateral? And then next, taking on the parallelogram, and that's the extent of our lecture for today. So if I'm looking at a quadrilateral to start, I'm looking at any four-sided polygon. Okay, eventually we're going to look at our parallelograms, and then we're looking at the rectangle and rhombus, which share the properties of the parallelogram, and then a square, which shares the properties of a rectangle, rhombus, and parallelogram. Okay, and then in a few days, we're going to cover the other types. So we'll look at trapezoids and isosceles trapezoids and kites. So first off, we're just looking at quadrilaterals. So first, I'm giving you this diagram. I have certain angles marked, and I'm saying solve for x. So what I have to remember is that the sum of the interior angles for any quadrilateral have to be 360. So to remind you of that formula from first semester, I'm looking at n minus 2 times 180. So I have four sides, so I have two triangles when I connect to one vertex. So 2 times 180 confirms that sum of 360. So it doesn't matter what type of quadrilateral it is. I should know that the sum of all of the interior angles has to be 360. So now I need to connect a few dots. I know that vertical angles are congruent. So this angle right here would be 96 as well. I know that linear pairs are supplementary. So 180 minus 104 would be 76 degrees. So if I'm looking to solve for x, I know that x plus 62, 96, and 76, that's 234, will be all equal to 360. So then the last thing to do is take away the 234 from both sides. And I end up with x at 126. Okay, in my second example, I'm calling a quadrilateral frog, F-R-O-G, and I'm telling you that the angle measures are in a ratio of 1 to 2 to 3 to 4. So let me draw a picture just to help me visualize what that's saying. I am not drawing this to scale, I'm just giving myself a visual anchor. So I'll call the one x, and then the next one 2x, and then 3x, and then the 4x. So that ratio of 1 to 2 to 3 to 4 is nicely reduced. I need to figure out what is x, what is the multiplier that is making all of these angles grow to sum to 360. So now I'm going to solve for x. I'm going to take the x, the 2x, the 3x, and the 4x, and make it all equal to 360. So now if I add those x's, I have 10 of them, all equal to 360. Divide each side by 10, and I see that x, that multiplier, is 36. So each of these, when I plug in 36, right here I would have 36 degrees, 72, 108, and 144. So 36 was that multiplier that makes all of these angles 36, 72, 108, and 144. So if I divided that away, I would be back to this initial ratio of 1 to 2 to 3 to 4. Now if I'm asking for the largest angle measure, I'm looking for the one that I've defined as 4x. So 4 times 36 is 144. So the largest angle in the group has to have a measure of 144. All right, next up, we're looking specifically at the parallelogram. So a parallelogram, it's pretty self-explanatory by its name, right? It's a type of quadrilateral that has two pairs of parallel sides, right? That's why we call it a parallelogram. Often I just abbreviate, I call it a p-gram if I don't want to write out the whole thing. All right, we have certain properties for every parallelogram that hold true. And we actually proved some of these properties early on when we were talking about triangle congruence. And now we're just formalizing these properties. So the first one is that we have two pairs of opposite sides congruent. So here and here. So two pairs of opposite sides congruent. We also have two pairs of opposite angles congruent. So this pair of angles and this pair of angles. Okay, diagonals bisect each other. So this diagonal gets split into two congruent parts. The other diagonal gets split into two congruent parts. Okay, this is the longer diagonal, this is the shorter diagonal, so I expect this one to have a bigger measure than this one right here. Okay, lastly, we see that four pairs of consecutive angles are supplementary. So consecutive just means right next to each other. When we were looking at parallels and transversals, we called them same side interior angles. It's the same thing. So where that's coming from, right, we know that our opposite sides are parallel, also congruent, but this relationship stems from the parallels. So let's say that I focus on here as one pair of parallels, and then here as my transversal. Then I can see it a little bit more clearly. 1 and 4 would be same side interior angles. We now call them consecutive. And it would be the same thing for 1 and 2, 2 and 3, 3 and 4. So measure of 1 plus 4 would equal 180. Same with 1 and 2, 2 and 3, 3 and 4. So we have four pairs of consecutive angles. We could also call them same side interior that are supplementary. Their measures add to 180. All right, so now we have what I usually call a parallelogram puzzle, where I give you certain information as a starting point, and then we connect the dots and we try to figure out other information building on what we were given. So I'm going to start by labeling all the givens. So AD is 2.75. AB is 4. BD, so this whole span here is 6. The measure of DAB, so this full measure here to here is 120. And then the measure of DCE right here is 50. All right, so let's connect the dots. I usually fill in as much as I can before I look to the right. So I know that my opposite sides are congruent. They're parallel and congruent. So if this is 4, this side is 4. If this side is 2 3/4, so is this side here, 2.75. Okay, my diagonals bisect each other. So if this is 6, it's being split as 3 and 3. I don't know the other diagonal. I was not given it, so I can't connect any pieces there. So now if I build off my angles, I know that my opposite angles are congruent. So if this is 120, this is 120 right here as well. Which means that right here, this has to be 70 degrees, because 120 minus 50 leaves me with 70 degrees. I know that my consecutive angles are supplementary. So if this is 120, right here would be 60, right? It's the supplement of 120, 60. And then this full angle right here will also be 60. Here they are opposite angles. Here we would have consecutive angles. Opposite are congruent. Here, consecutive are supplementary. So just a reminder there. Okay, one other thing that I can do is I can build off this angle of 50 degrees. Let me show you how. So if I take my colors, I know that my opposite sides are parallel. So if I emphasize here and here, for example, right, those are parallel, and I picture my transversal right here in blue, then I can connect some alternate interior angles. So where I have the 50 right here, this would be the alternate interior angle right here. So right where that 50 is, here, it will be 50 right here as well. Which means that if this is 70, right, this has to be 70 as well. I could view this pair of parallels with this transversal. I have the same relationship. So I'm just looking at alternate interior angles. Remember that your alternate interior angles are congruent. So a little carryover from last semester. So now filling in my gaps, a DC has a measure of 4. A BC here, 2.75. DE right here is 3. Measure of ADC right here is 60. A measure of BCD, so BCD, this full one is 120. ABC, that full one is 60. BAE, so BAE right there was 50. Again, we connected alternate interior angles. And then DAE right there is 70. All right, I love these types of problems. It's like a little mini puzzle, and I'm just connecting the dots. All right, let's look at the back. All right, so more with parallelograms. So here we're told that this is a parallelogram. We know all of those properties apply. And we're told that the measure of angle ABC, so this measure right here, is 3 times the measure of BCD, so this measure right here. So we've handled problems like this before. We're defining one angle in terms of the other, and we're saying that one angle is 3 times the other one. So let's say that I call this one right here X. Then ABC would have a measure of 3 times X, like that. So remember that the angles now that I know, that I've defined as X and 3X, those are consecutive angles. And I know that consecutive angles, they are supplementary. So if I want to solve for X, I can say that X plus 3X equals 180. 4X equals 180. Divide by 4. And X is 45. So if I mark angle C right here, that is 45 degrees. 3 times 45 would be 135 degrees. What am I asking for? I want the measure of ADC. I want this one right here. So now remember that your opposite angles are congruent or consecutive angles are supplementary. So right here I get 135 and this one would be 45. But the one that I wanted was right here, 135. Okay, so next up, here again we have a parallelogram, ABCD. I'm telling you that the measure of ADB is 50. So I'm going to go ahead and label what I'm given. So ADB is 50. The measure of BDC is x squared. So right here is x squared. Okay, ABC is 15x. So here to here is 15x. Okay, I'm also told that ABC, this angle is acute, right? It looks acute, but I could solve and get another answer that could potentially work. Let me just slide this up. So acute means that all of the angles, right, all of those interior angles, right, if it was a triangle, right, have to be less than 90. So if it's just here, if I'm looking at just an angle in general, it just has to be less than 90. Okay, so acute, less than 90. All right, so whatever we get for x when we plug it back in, that angle measure, it better be less than 90. So how do I solve for x? I can see that I have opposite angles marked, and opposite angles are congruent. So I can build an equation that x squared plus 50 is equal to 15x. So now I recognize, oh, it's a quadratic equation. I want to pull to one side and then make it equal to 0. So I'm going to subtract that 15x over. I have x squared minus 15x plus 50 is all equal to 0. All right, so now I see it's a quadratic equation. It's set equal to 0, and now I want to factor. So I'm looking for two numbers that multiply to 50 that add to negative 15. All right, so I can see that that should factor into then x minus 10 times x minus 5. Okay, all equal to 0. And then when I solve, I get that x could be 10 or x could be 5. So if I plug back in, let's say that I tried that 10, let's say I plugged it back in here, that would give me a measure of 150. That would violate what I'm told right here, that my angle has to be less than 90 because it's acute. So here, this one is not going to work because it would create ABC larger than 90. It would not be acute. Right, it would give a measure of 150, and it has to be less than 90. So let's try that 5. So if I plug in a 5 times 15, this full measure would be 75. Okay, 5 squared would be 25. And that makes sense. My opposite angles would be congruent. Okay, now I'm asked for the measure of BDC. So if I want BDC, that measure is 25 degrees. All right, next up. ABCD is a parallelogram. We want to find x and y. So if I look at what is marked, first thing that I can see is that I have a pair of opposite sides. I know my opposite sides are congruent. And I also have a pair of alternate interior angles that are congruent. So it doesn't matter what you start with. Let's say that I start with the opposite sides congruent. then I know that 2x minus y equals 20. Okay, well, I have two variables. That's not helpful. I can't solve for x or for y just yet. I also know that my alternate interior angles are congruent. So I know then that 3x plus 5y equals 56. And I see the same problem, right? I see x and y, and then I see a constant, but I can't solve for just x or just y. But I do have these two equations. They both have the two variables. They're both in standard form, so we could join forces and build a system. So I'm going to say 2x minus y equals 20, and then 3x plus 5y equals 56. So when I'm solving a system, right, I could solve using substitution, or I could use elimination. I like elimination, and it looks pretty easy to make opposites in the y. So if I have 5y here, I can make the top negative 5y if I multiply everything on top by 5. So now, next stage, I have 10x minus 5y equals 100. And then I have 3x plus 5y equals 56. So now add down. I have 13x equals 156. Divide each side by 13, and I get that x is 12. So I know what x is. X has a value of 12. And then to get to y, I'm just going to plug back in either equation. Doesn't matter which one. So if I look at that top one, the 2x minus y equals 20, I know that 2 times 12 minus y equals 20. So 24 minus y equals 20. Take away the 24 from each side. Negative y equals negative 4. Divide each side by negative 1, and we get that y is 4. All right, so for this one, I just had to use some properties to build two separate equations. Both equations had two variables, so I joined forces right here, built a system, and then solved my system using elimination. You could also use substitution. That would be fine as well. All right, last up, I'm looking at a figure on the coordinate plane. And I'm saying, can you show me that this is a parallelogram? So let me zoom in. So if this is a parallelogram, there's a couple different routes that I could take. I could do something very simple and just show that I have opposite sides that are parallel. That's probably my easiest route. But I could also show that my opposite sides are congruent, or that my diagonals bisect each other. And all of those paths would get me to my shape, my quadrilateral, being a parallelogram. So for me, I'm going to go through the opposite sides. I want to show that I have both pairs of opposite sides that are parallel, that they have the same slope. So I'm going to take a moment and I'm going to find all of my slopes. I'm going to look for what is ST, what is its slope. Okay, I'm going to look for PO, what is its slope. Okay, same with SP and TO. So remember that same slope means parallel. So ST, so if I count up 1, 2, 3, 4, 5, 6, 7, 8, and then write 1, so 8 to 1 is 8. I want to make sure that PO is the same. So 1, 2, 3, 4, 5, 6, 7, 8, and then 1 over. So I do see the exact same thing. PO has a slope of 8 as well. So I know that these opposite sides are parallel. They have the same slope. If I do the same thing with SP, Here I'm going down 1, and I'm going down 2. So I'm going down 2 and right 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So down 2, right 10. My slope is -1/5. Okay, TO, I want to make sure it's the same. So I'm going down 1, 2, and then right 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I am seeing the exact same slope, -1/5. So these sides are also parallel. I can show that with my double arrow. So again, that tells me that my figure is a parallelogram. So it is a P-gram. See, here's where I'm going to abbreviate because both pairs of opposite sides are parallel, right? We saw the same slope. So we saw that ST was parallel to PO, right? Their slopes were both 8. And we saw that SP was parallel to TO. Those slopes were both -1/5. Okay, so also just one more thing to point out. Again, I said it already. If I didn't want to show my opposite sides are parallel, I could have shown my opposite sides are congruent, or that my diagonals bisect each other. So splitting them into 2 congruent parts, they would have the same midpoint. So there's other ways of doing it. This is the most efficient pathway. All right, one last one. Find perimeter and area of parallelogram crab. So I just want to remind you of the formula for a parallelogram. It is the same as a rectangle. So picture, again, here is my parallelogram. So here is my base, and that perpendicular segment that connects to the 2 bases, right? We know that its measure is the height. So what I'm picturing is this right triangle right here. Picture it cut out and then slide it over to right here. And you can see that by cutting off that portion and reconfiguring it over here, we've just made it into a rectangle. So a parallelogram has an area of just base times height. We just have to make sure we find that appropriate segment, right, that's perpendicular and connecting the base to the other base. All right, so I need to find my perimeter and my area. So let's find our perimeter first. Let's find all of our sides. CR and BA are pretty obvious, right? Because it's a horizontal path. Same if it was a vertical path. So if I count across, I should see that this span here is 10 units. Here also 10 units. If I want to picture what CB is, remember I can make that right triangle. Let me draw it in like so. So I'm picturing this right triangle, and I'm really using Pythagorean theorem to get to the hypotenuse. So right here, this span is 8, this span is 2. So I can do square root of 8 squared plus 2 squared to get to the hypotenuse. So I have 64 plus 4, which is 68. So I have root 68 right now. So that is the same thing as 4 times 17. So I end up with 2 root 17. So the measure of CB is 2 root 17. And if I go over here, is RA the same triangle where I have a leg of 2 and a leg of 8? Here's the 2, here's the 8. So yes, it will have the same measure then of 2 root 17. All right, let me label that. So 2 root 17, 2 root 17. So my perimeter, I'm really just adding up all my sides. So I have the 2 10s and the 2 root 17s. Okay, I can only combine radicals if they have the same radicand, so I can combine right here. So I'm going to end up with 20 plus 4 root 17 units. So a little u for units. Okay, my area, so again, I'm picturing my parallelogram, but I'm looking at that perpendicular segment that connects the two bases. So my two bases, they're both 10, right? This whole span is 10. And then the height, that perpendicular segment that connects them, is the 8. So if I'm just doing base times height, 10 times 8, I get 80. So 80 units squared for my overall area. Again, I can picture here, if I go back to that visual, I can picture this right triangle, right, cut it off and slide it into this position, and I can see how it makes a rectangle. All right, that's all I have for today. Have a good rest of your day.